Hello and welcome back to another video. In this problem we're asked to find the exact value of each expression. So here we have cotangent inverse of the negative square root of 3. This is equal to some value x, and we want to find x. We know, therefore, that cotangent of x equals negative square root of 3. Right? When you're undoing the inverse, you can swap the variables. Since this is 1 over tangent of x is equal to the negative square root of 3, tangent x itself equals, we can swap these, 1 over negative 1 over the square root of 3. So we have to find a value of x for which tangent of x equals negative 1 over the square root of 3. However, there's infinitely many values of that because the tangent function looks like this, right? It's periodic. This is not a one-to-one function, right? It fails the horizontal line test. Therefore, when we're taking the inverse tangent and therefore the inverse cotangent, we're only looking at this little period right here. And therefore, when we are calculating the inverse tangent function, it looks something like this. So that's going to help us because we're going to use a triangle to find when the value of tangent is equal to this. But triangles are physical representations of things. The angles are positive, right? Here we have a 30, 60, 90 triangle. The side lengths are positive, the tangents are going to be positive. So when we see that the ratio of these sides is 1, root 3, and 2, and therefore the tangent of 30 is equal to the opposite 1 over the adjacent side, root 3, and therefore the tangent of pi over 6, because we're not doing in degrees, we're doing in radians always, is 1 over the square root of 3. This is great, but it's not negative 1 over the square root of 3, and we can't find that with a triangle. However, if we know that for pi over 6, the function is at this value, we know at negative pi over 6, it's at the negative version of that value. So if tangent of pi over 6 is 1 over root 3, then we know that tangent of negative pi over 6 equals negative 1 over root 3. And therefore, going back all the way to the original function, cotangent inverse of negative square root of 3 is equal to our answer, negative pi over 6. Next up, we have to find, let me separate it like this, the inverse secant of 2. Inverse secant of 2, we find this by setting it equal to some y. And therefore, this is saying that secant of y, as I lose my ink in my pen, secant of y equals 2. Secant is 1 over cosine, so 1 over cosine y equals 2. And therefore, cosine of y equals 1 over 2. This is positive, so we don't really have to worry about the graph because when we look at the triangle, we, say 30, 60, 90 triangle, where the side lengths are as such, the cosine of 60 degrees is the adjacent side 1 over the hypotenuse 2. Therefore, the cosine of 60, which we're doing pi over 3, because again we have to stick with radians, is 1 over 2. If the cosine of pi over 3 is 1/2, then the secant of pi over 3 is 2, and therefore secant inverse of 2 equals pi over 3. And maybe that was a step I should have done here. The tangent of negative pi over 6 is negative 1 over root 3, then cotangent negative pi over 6 equals negative square root of 3. And therefore, you're able to see more clearly the difference between the inverse and the actual function. Cotangent of this equals that. Therefore, cotangent of that equals this, right? We're swapping the inputs and the outputs. 2 goes into the function. Pi over 3 goes out of it to get to the inverse. So therefore, our answers in this problem are negative pi over 6 and pi over 3.